Okay then, look at this question. It says the diagram shows the sector of OACB of a circle with a centre 0, where C is the midpoint of the arc AB. The diagram shows a hollow cone with vertex, which means corner, 0. The cone is formed by joining OA and OB. Now, initially, this is a really hard question to get your head around, just purely in terms of visualising what it looks like. So basically, this thing here, if you cut one of those out yourselves and just joined OA and OB together, it would form a cone. So it would just literally just get pushed together and it would form this standing up cone, okay? So we're then told that the cone, so this is not the circle now, the cone that it's made, has a volume of 56.8 centimetres cubed and the height of 3.6 centimetres. So the first thing I'm going to do is actually just go and draw that in. So I'm going to draw the centre there, and then if I label up this cone properly when I'm finished, you'd have then going over would be the radius. So I don't think we're told the radius at the moment, so I'll just leave that as R, but I'm probably going to have to find it. O to the centre there would be the height, so that is 3.6 centimetres. And then as you can see here, you've got this length, which is like the sort of diagonal. Obviously, I've got a right angle triangle, so I could find that by using Pythagoras. Okay then, so first things first, we're asked to go and find the size of OAB of sector OACB, and again that is a mouthful in itself. So OACB, O to A to C to B. So it wants me to go and find out what is this angle here. What's that? Okay, that's what it's after. And it wants me to round that to 3 significant figures. Okay, I will when I get there. Let's go to this statement here. The cone has a volume of 56.8 centimetres cubed and a height of 3.6 centimetres. We can see here we've got a formula to work out the volume of the cone. So the first thing I'm going to do here, I'm just going to lay my strategy in the bits that I've done it in, is to say that the volume of the cone is equal to 1/3 of pi r squared h. Now h is the height, the right angle height up here. So I'm just going to start substituting into that now. So that's going to be 56.8 is equal to 1/3 of pi r squared. And that's going to be then times by the height, which is going to be times by 3.6. So what I want to do now is start rearranging this this line here and starting to find out what the value of r is. So the first thing I could do is times both sides by 3 just to get rid of that third. So 56.8 times by 3 gives me 170.4. So 117.4 equals pi r squared 3.6. Now, because multiplying is what we call commutative, i.e. we can do it in any order, then what I'm going to do is then take this times in by pi and this times in by 3.6 over to the other side. So I'm dividing both sides by pi and 3.6. So I'm going to get 170. I'm aware you can't see what I'm writing down, so I'm just going to slightly move the camera. There we go. Over pi times by 3.6, which is going to leave me r squared. In fact, actually, while I'm at it, I'm going to square root both sides. So that would cancel out the squared, r squared, and leave me with that answer there. So I'm now going to put in square root of 170 over pi times by 3.6. So I'm putting all of that in so you can see it. And I press equals, and I get the answer 3.877. Now, the main thing you should not do is not round that answer yet because we aren't finished, okay? I might go and write down here that it's 3.88 to 3 significant figures. However, it wants to know what my final answer was. So I'm actually going to leave that in my calculator like that and use it as ands when I need to. So what I've got now is 3.88 centimetres to 3 significant figures. But how is this going to help me work out what this is here? Well, it's not, and it is not that length there. Okay, now that is a radius, but it is not a radius of the shortened down cone. And I think that's probably one of the harder things to work out here. Now O to A is O to B, so that's the same at start and end point. That's the radius of the circle that I want to work with. However, it's actually the length of this one here. So my second strategy is going to go to work out what that length is there. I've got a right angle triangle, so the L squared must be equal to 3.6 squared plus the other one, plus the radius, so 3.87, as my calculator says, 7 blah 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 squared. So into my calculator I'm going to put 3.6 squared plus answer squared and press equals and get 27.9913 ... Not finished, so I don't round it. So not L squared, sorry, I'm going to square root that now, that number. And that's going to tell me what L is. So square root of answer is 5.29. Again, to 3 significant figures, yes, but I don't actually round just yet in my calculator. Okay, so now I know what that is. That's 5.29, ... That's what the radius is. That's 5.29 over here. So now I'm actually starting to get really close to being able to work out the angle here. That I know that this angle, the formula that I would use this normally would either be circumference or area. I suppose I could try and work out circumference or the area. We'll see which one's probably easier to work out in a second. So you do the angle over 360 times by pi r squared if you're doing area would equal that area. And if you're working out what we call an arc length, you'd still do exactly the same formula, but you'd times it by 2 pi r, which is the formula for circumference. So it's part of the circumference. That's what we call an arc. So I'm going to just look at my formula here, and it says to work out the curved surface area of a cone, you just do pi times r times L. Well, I've just worked out L. I know what the radius is. So the radius of this cone here is 3.88. And I know that L is 5.29. So what I'm going to do now, as my third bit of strategy, is work out the curved cone area. So I'm just literally going to do pi times r times L. Now this is where I've come into a little bit of a problem here. So I've got this answer here, this 5.29, but I have rounded it on my paper and I want to use it as ANDS in my calculator, but I also need to use ANDS that. So rather than putting in r, I'm going to put in the formula that got me r. So all I need to do is do pi times by that 3.88 answer and then times by the 5.29 answer, and that will tell me what the curved surface area of the cone is, which is actually this bit here. This is the same thing here. So I'm going to put in pi. I'm going to put in the formula that got me the radius of the cone, which is 170.4 over, oh hang on, I need to put in square root there. So square root of 170.4 over pi times by 3.6, close the bracket there, and then I want to times it by the answer that I know my calculator is currently holding, but I need to make sure that that square root now is finished. So times that by the answer, and I press equals, and I get syntax error, which isn't great. That's purely because that bracket there is inside the square root, so I should just move to the side there, and I move that bracket over. I press equals, and I get that the curved surface area is 64.5 to 3 significant figures, but as always, I haven't actually found the question yet, which is to find the angle. So I'm just going to leave that in my calculator for now and not delete it and use ANDS. I think we're pretty much there now. I think I can use this one because I've actually got the area bit here. The radius I know is that 5.29 answer. And then to get to the very, very final bit here, to find out what this angle is, I need to do this fourth and final stage. So I'm just going to come and move up to here. So for number 4, I'm going to say theta, the angle, which I don't know, over 360 times by pi, times by the radius of this thing. So this is 5.29. Now I will probably just round off there because I haven't done it yet. I've gone to 3 significant figures there, and I know that this area is a bit of a nasty one, so I don't want to have to keep on going back. I've been really consistent throughout, and I am on the very last line of work. That's equal to 64.5 ... So now I just want to rearrange. So the easiest way to do that to begin with is to divide both sides by pi times by 5.29. So that's 64.5 divided by 5.29 times by pi. So I'm going to get theta over 360 is equal to that answer over pi times by 5.29. Really, that should be longer, but I can't put both answers at the same time. I've made a mistake here. It's pi r squared. So if I can get back this answer here, 64.5, let me just make a note of it, 64.5. This is the only problem now, because that's my answer and I've used ANDS throughout. I've got a real issue if I accidentally put the wrong calculation in. It can happen to any of us, as you've just seen, okay? So I'm going to write in 64.5163883, and that is over pi times by 5.29, and then that's squared. and I get 0.733 blah blah blah. And then finally, to find out what that angle is, I times both sides by 360. So timesing that by 360 gives me an answer of 264.2. Oh no, to three significant figures, 264 degrees to three significant figures. Thank you very much for watching.